So again, this is also similar to the previous question that we discussed just now. Yeah. Now, in the previous question we were talking about gold, but here we are going to talk about copper, right? So copper means Cu, right? So Cu is a 3D transition element. Now, from this atomic symbol, what are the things that you can extract? A is equal to 69, 63, and Z is equal to 29, right? So now they are asking the number of protons, right? So which combination of protons, neutron and electrons is correct for the isotope of copper? Now here, since the atomic number is 29, the number of electrons and the number of protons should be equal to 29. So here look at this, 29 proton and 29 electron. That is the answer. Yeah.
And how did we get 29 again? Because we. Oh,
Right.
wait.
See this one. Okay, right. So here, for example, if you take a typical element X, right? So here we will have A and here we will have Z. So how do we call this Z? Atomic number.
Atomic number.
Atomic number. And how do you call this A?
Atomic.
Uh,
Is it atomic mass?
no, mass number. Yeah,
Mass number, yeah.
mass
Mass number,
number.
not atomic mass.
Right. So now for an atom, right? So for an atom, and we have two things, right? For an atom and for an ion. For an ion, right? For an atom, the Z atomic number is equal to number of proton, which is equal to number of electrons. Yeah.
Right.
And atomic number will be equal to number of neutron plus number of proton. These two equations you should bear in mind. And for an ion, atomic number will be equal to number of proton, but that will not be equal to number of electrons. Why is that?
Yeah.
Why is that? Because ions are formed by the adding or either by adding or removing the electrons from the neutral atom. Yeah. In the previous class we discussed. Do you remember? How do you form ions?
Wait.
Hmm?
One more time. This is my. One more time, please. This is my headphones.
Okay. Right.
What's it?
So okay. Right. So for example, Na plus. How do you form this Na plus? By removing one electron from the sodium atom. So here for an ion, that will not be, number of electrons will not be equal to the number of protons, which is equal to atomic number. Yeah. Okay.
Yes.
Right. Now if you apply this theory here, now they are talking about copper, right? So here instead of
Right.
X we have Cu, right? So let me erase all these and explain. Right. So here look at this question. Here this is atomic. This is mass number. 63 is mass number and 29 is atomic number Z. Right. So Z is equal to 29. So we have a relationship. Z is equal to P is equal to E. Right. So since
Right.
the atomic number is 29, the number of protons and the number of electrons also should be 29. Did you understand that now?
Yes.
So the answer should be A. Look at the other responses. Here 29p okay, but not 63 electrons. No. Because
No.
63 is mass number. It cannot be equal to the number of electrons. And here
Electrons. Yeah.
34 is also not correct. Here again 63 is not correct. And here also 63 is not correct. Why? Because the number of protons cannot be 63 for an isotope. Right? Here 34. Right. So the answer is directly A. Now shall we confirm our answer by calculating the number of neutrons? How can you do that?
Yes.
Simply
29 plus 34.
Huh? No. So how do you calculate neutrons? N is equal to A minus Z. A minus Z.
3.
So what is A? This. The upper number or the subscript number. So the superscript number minus subscript number. Right? So
Right.
here 63 minus 29. What is the answer?
Is it 46?
63 minus 29? Oh, can you use calculator in the exam?
Yes.
So you can use the calculator to find out. Otherwise, 63 minus 29, right? So we bring 1 from here. So 13 minus 9 is 4, right? And we have brought 1 from here. So the remaining is 5. 5 minus 2, 3. So what's the answer?
34.
34, right? 34. So here 34 neutrons, and you can see here the charges of positive is proton is positive, here neutron has no charge, so 0, electron negative charge. Yeah. So now you should know how to calculate the number of neutrons in an atom or isotope. So how do you do that?
You make it a negative?
Yeah, how do you calculate the number of neutrons? Simply mass number minus atomic number, which is equal